Hi everyone, and welcome to the IMIM seminar series. It's my great pleasure to introduce today's speaker, Professor Tarek Hassan. Tarek is currently a professor of economics at Boston University. His research fields are international finance, asset pricing, political economy, and economic growth. His work has made important contributions to these areas and has published at top journals such as Quarterly Journal of Economics, American Economic Review, Review of Economic Studies, Journal of International Economics, Journal of Finance, Review of Financial Studies, and so on. In today's seminar, Tariq will present his paper titled The Currency Risk Premium Puzzle. The format will be a 15-minute presentation followed by 10 minutes of discussion and questions. We are very fortunate to have Professor Dongchen from Indiana University as the discussant of today's seminar. Without further ado, Professor Hassan, all the floor is yours.
Thank you so much, and this is great. Thanks for inviting me. Can you just clarify, how long do I have? 15 minutes?
Yes.
Oh, okay.
No, 50. 50.
Oh, 50.
50.
Okay. Well, okay, good. I would have swapped out my slide deck. It's actually fairly simple to explain. So let's see. This is joint work with Thomas and Jinye. I think probably for this crowd, I don't need to motivate too much. So there's been a surge in interest in the role of risk premia in international finance and macro, and I'm kind of happy to report that the macro people are coming around to this view as well. So risk premia are important for understanding exchange rates, interest rates, capital flows, and financial stability. Nevertheless, we lack a quantitative model that can reconcile the observed behavior of exchange rates with large and persistent differences in interest rates across countries. So, for example, New Zealand and Australia persistently have a 3 to 4 percentage point difference in risk-free rates relative to Japan and the United States. And a 3 to 4 percentage point difference in risk-free rates is going to translate into very large differences in the cost of capital and therefore in the allocation of capital across countries. So in this sense, I think that the lack of such a quantitative model is a key roadblock to understanding the effect of risk premia on the allocation of capital across countries. And I think it's also the key roadblock to having essentially disciplined models of things like the global financial cycle and so forth, right? So this is really at the core of what we do. So what we do in this paper is we highlight a fundamental tension between canonical asset pricing models that are usually responsible for providing models of risk premia and the empirically observed behavior of interest rates and exchange rates. And we're going to call that a currency premium puzzle. Effectively, we tried to build such a benchmark model that can reconcile the observed behavior of exchange rates with the observed behavior of interest rates across countries. And we failed, and we figured out why we failed, and we just want to sort of report this back to the profession. This is going to be a heavy lift, I think, to understand. So in the data, exchange rates are largely unpredictable. This is sort of the famous Mies and Rogoff fact. And differences in interest rates across countries are large and very persistent. So this is a paper I have with Rui and DQJ in 2019. So our main findings are, the first main finding is that risk premia in models with symmetric long-run risk and habit preferences struggle to jointly match these facts. So any model that's going to start with like an Epstein and Zinn utility function in the long-run risk spirit or with habit preferences is going to struggle reconciling these two facts. These canonical models require, if you plug in the numbers that people like to use in asset pricing, that the vast majority of any differences in currency returns manifest as predictable appreciations of one exchange rate relative to the other, with only tiny interest rate differentials. In other words, these preferences, if you use these preferences, they don't allow you to generate large persistent differences in interest rates. this counterfactual prediction is hardwired into utility function. So it's really kind of independent of what you kind of model about the structure of the economy, whether you have like a model of like intermediary frictions or, like what population, like what kind of populations you put into your model. It comes straight from the utility function. And as a result, it affects virtually all leading international macro models that have asset prices and macro quantities, including the ones that we really like and that we think are at the cutting edge. I just want to stress that market incompleteness and non-normal shocks are no easy fix for this problem. Okay, so let me let me kind of briefly kind of relate this to what you already know. So there's a giant literature on the macro and financial effects of international risk premia on, things like sudden stops, the global financial cycle, interest rate differentials, violations of uncovered interest parity, and so forth. What we do in this paper is we basically highlight a major challenge to the development of this literature. So this literature is in some sense a hybrid between macro and finance, and we're pointing out a point of friction between these two literatures. There's of course an even larger literature on classic approaches to the equity and risk-free rate puzzles. And another way of kind of processing what I'm trying to say here is that basically the international data, when you look at data on exchange rates and interest rates, those place new restrictions on how these approaches can work. There's a large number of models of basically violations of uncovered interest parity that are kind of stylized and not quantitative. And these models typically trace differences in interest rates across countries to differences in the economic environment. So in my own work, it's like differences in the size of countries. And Rob's work, it's differences in the trade centrality, and Reddy Rusanov words, it's differences in like what you ship across countries and so forth. There's a long list. And essentially what we're highlighting here is that this problem that we highlight is basically a problem for making any of these models quantitative with the standard tools that we have developed. Okay. So let me kind of start with like so I'm going to basically kind of give you a picture of the problem before showing. I'm going to explain the problem in a general way, and then I'm going to go to the long run risk model. I'm going to give you a basic framework. Then we're going to go to long run risk model. Then we're going to go to habit models, and then we'll see if we have time for the rest. So the fundamental equation of asset pricing, we start all of our lectures with it. 1 equals E of MR. If you have no arbitrage and log normal shocks, you can write this. I'm going to say later, like log normality doesn't really matter for this. But the point is that so the risk-free rate has something to do with the mean and the variance of the stochastic discount factor. Now, when we teach this equation, we kind of say, well, there's kind of two parts of it. The equity premium puzzle is that, basically we need the variance of M to be really high. And the risk-free rate puzzle is that we need the sum of the mean and the variance of the SDF to be low and stable. So that's kind of like how in Campbell's textbook we explain what the equity premium puzzle is. So at some level, if we could make the risk-free rate whatever we wanted, it'd be simple to just have a high variance of that. What I'm going to show you, and this is something that although I've been teaching this for years, I only realized recently. So it turns out that canonical long-run risk and habit models, and we've kind of all written these equations, but like maybe not thought about it quite this way. So canonical long-run risk and habit models achieve this, so they solve this problem by creating a nearly one-for-one offsetting functional relationship between the mean and the variance of the SDF. So basically what these preferences do is the preferences make me care, like for example, in long-run risk, they make me feel bad today about future uncertainty. Right? So what they do is they create a link between these two moments that doesn't exist under constant relative risk aversion. And what that link does is it basically ensures that whenever this goes up by 1, this will go down by 1. That's the basic thing that they do. So whatever increases the variance of M also has to decrease the E of M by a similar amount. And if you do that, then obviously from this equation, you're going to have a stable risk-free rate. So this trick fundamentally is going to be a problem in the open economy, and let me explain why. So, and it's actually kind of really fairly simple to see in this kind of graph. It's a slight variation of what you saw in a lecture on Hassan and Jagannathan at some point, probably. So I'm basically going to take this equation here and I'm going to put it in a graph. And I'm going to draw what I would call iso risk-free rate lines. So I'm going to put the E minus E of M on the vertical axis. You'll see why in a second. And I'm going to put the 1/2 variance of M on the horizontal axis. So in that space, then my interest rate equation becomes like a straight line with a slope of 1. And I can basically pick the level of the interest rate. And then basically what this here says is that this here's a low interest rate line. All the combinations of so if I now put an SDF, like a combination of mean and variance of the SDF into this graph, it's going to tell me what is the risk-free rate. And all the combinations of the mean and the variance of the SDF that are on this line are going to all produce the same risk-free rate RF here. And the same is true for like the higher interest rate up here. So the higher the risk-free rate line, the higher the interest rate. So to cut straight to the chase, I'm going to show you formally that essentially if you go to the Banzhal-Ligneron parameters and you put in an Epstein's-in utility function, it's actually going to tell you that anybody who has this utility function with these parameters is only going to be able to produce combinations of the mean and the variance of the SDF that are on this red line. So regardless of what happens sort of in the real economy around you, your combinations of E and var of M are always going to lie on this line. And the key reason why the long run risk model fixes the equity premium puzzle in the way that we've come to think about it is because it's doing that. So this is so essentially if you ensure that the E and the variance of M are always on this line, you can push the economy over here to the right and have a high variance of M without screwing up your risk-free rate because you're always going to be on the same risk-free rate line. So variation in risk premium is going to therefore manifest in quantitatively large differences in E of M, but not interest rate differentials. So let me show you this. So let's put some numbers on this graph. So what's a big number here? So let's say, the Hansen-Jagannathan bound says, well, in order to get like an equity premium that's large, we need to get the standard deviation of M to be 0.5. So let's do 0.5 squared. So the variance of M needs to be 0.25. And 1/2 that is 0.125. So typically, we find it very hard to get the model all the way over here, right? So this, going from here to here is a really large distance in the variance of M. This is kind of like heavy lifting. Does that make sense? So 1/2 of variance of M of 0.125 is like kind of the edge of what we're able to do in most models. Okay. So now what does this say? So let's say I have one country that has a really high variance of M, like here. And that's going to have an interest rate of, 0.01. All right. So now I'm going to have a model why countries differ in risk. So that's fundamentally a model of why countries have different variances of M. So let's say I have one that has like half as much variance of M, like over here. Now, okay, great. So now, what happened? Well, the interest rate still does the bloody same. What happened is because we put in these, so what the long run risk model tells you is that if you have large differences in variance of M across countries, you're going to have large differences in E of M across these countries, but not large differences in interest rates. And that fundamentally is going to be the issue. So there's basically two implications from this. So can I just pause? Like this is basically the paper. So like if you have any questions, you can ask them now. So this has two key implications. The first is that in some models, when we say like the allocation across the two countries is efficient, if the allocation of across the two countries is efficient, then the difference in the E of M's between the two countries tells you something about the predicted depreciation. So what this here says is that if I put in a large difference in the variance of M in a long run risk or habit model, and the allocation is efficient, then I'm going to have large predictable depreciations, and that's going to cause all kinds of problems because we know in the data that those don't exist. The second and more basic problem that exists even if markets are totally incomplete is that even if I kind of forget about the link between the E of M and the exchange rate, the fundamental problem remains that, like, I would have to make the difference in the variance of N between these two countries so giant that it's like off the slide to get any meaningful differences in risk-free rates, because this red line has almost a slope of 1. And that's okay. So I'm going to now spend the rest of the talk explaining this a little bit better. So let me back up a little bit and explain kind of what is the relationship between the axes of my graph and the FX data. So if FX markets are efficient, if markets are complete, then data on exchange rates and currency returns provide basically tell us where each country is in SDF in this SDF space. So, for example, you can show very easily, that the expected change in the exchange rate equals the difference between two countries' expected log SDFs. So, if I have a different expected log SDF from the other country, I'm expected to appreciate or depreciate. Yeah, it doesn't really matter which way around, but the point is I'm going to have exchange rate predictability, which is people expect the exchange rate to move. The data on the currency premium, like how much money do I make by borrowing in one currency and lending in the other currency, disciplines how far countries have to be apart on the horizontal axis. So it disciplines how big the differences in the variance of M have to be. Okay, and essentially, risk-based models of violations of uncovered interest parity or risk-based models of the carry trade are basically theories of why these variances here differ across countries, right? That's essentially what these models do. Okay, so with this in hand, I can basically now interpret the axes. And now let's say I have an efficient allocation. Okay, I'm going to kind of loosen that later. But let's say the allocation is efficient between the two countries. In finance, we like saying complete markets to this. I kind of don't really like that because it makes it sound crazy, right? So when I say complete markets, people think euro securities and I can like have a contract about everything and I've planned my entire life. That's not what you need, okay? What you need for this axis to say something about the exchange rate is that the allocation of resources between the two countries is efficient in the sense that the price of consumption is linked to the marginal utility of consumption. That's a pretty basic thing, right? It's going to be very hard to get away from, even if you loosen it, right? So, okay. So now let's kind of look at this. And I'm going to put two countries here. So Japan always has a lower interest rate than New Zealand. So I'm going to put Japan on this low interest rate line and New Zealand on the high interest rate line. So now the key is that the difference in returns between these two currencies is basically the horizontal difference here. So the difference in returns, according to this equation here, right, is just the difference, how far is the variance of their SDF apart. And, when I write about this, I like calling this differences in the riskiness of two different currencies. So how risky is the Japanese yen relative to the New Zealand dollar? Okay, so the horizontal difference is the how much can you pocket by borrowing in Japan and lending in New Zealand. So basically, how profitable is the carry trade between the two? And the vertical distance is how much of that profitability from the carry trade is coming from predicted depreciations of the New Zealand dollar relative to the Japanese yen. The slope in this graph between New Zealand and Japan is exactly the share of the returns on the carry trade that is coming from a predicted movement of the exchange rate. So the slope is the vertical distance divided by the horizontal distance. Does that make sense? All right, so now let's play with this a little bit. Okay, so I can now kind of house different models here. So if exchange rates are unpredictable, then the two countries have to have the same E of M. And in our example of like, if exchange rates are unpredictable and Japan has a lower interest rate than New Zealand, then this distance here is the profit from borrowing in Japan and lending in New Zealand. So this is what I would call unpredictable exchange rate is if this line is horizontal. This is the situation where New Zealand, a high interest rate country, depreciates relative to the low interest rate country, but not enough to wipe out the interest rate differential. So this is kind of what happens in the data. I'll show you that in a second. So we have interest rate differentials, and they're a little bit reversed by predictable depreciations, but not completely, which is why we have the carry trade. This here is what happens in macro models where there's no risk, right? So if you have a macro model and you've solved it to the first order and you haven't done the second order expansion, then the variance of M is the same everywhere, and all the countries are on top of each other, which is why macro models generally predict that uncovered interest parity holds. Macro models allow differences in interest rates to arise, but they have to be reversed by predictable depreciations of the high interest rate relative to the low interest rate country.
So,
Okay.
Tarek, does it mean that we will have homogeneous SDF because this is just one line for all countries?
Can you say that again? Oh, so this is it. Now I'm just talking about the data. So I'm gonna connect this to the theory in a minute. But this is just a statement about the data. I'm basically kind of just saying if I have this like space, I can take the high interest rate countries and the low interest rate countries and look at like where are they in relation to each other, and then that will tell me like that will put restrictions on what I can do with the E of M and the variance of M. That's all I'm trying to say here.
But do we require to have just one solid line that crosses all countries?
No, not necessarily. No, but I would say that we don't really have theories of why those lines would be different for different countries.
I see.
Or those are theories that are unappealing. I'll get to that a little bit later. Can you remind me of this? Yeah.
Yeah.
Okay, so here's like the data. We're not going to have to go through the details, but if you estimate this and you just instead of doing Japan and New Zealand, you just say, let me do a portfolio of low interest rate countries and a portfolio of high interest rate countries, and let's estimate the slope in the data. It looks like this. And this is effectively my paper with Rui, the point that we made in our paper, which is that the carry trade and basically major facts about returns on currency markets are all about interest rate differentials. And we can't really reject that exchange rates are unpredictable. So exchange rates don't really contribute significantly to the returns that people make from the carry trade. So this is kind of what the data look like. Okay. This is kind of a complicated way of saying that. So basically what the data tell us is that the variance of M's are far apart. The countries differ significantly in the variance of M so that we can get large differences in currency returns. And the FX share is weakly negative. The FX share is, something basically around zero and slightly negative. So the contribution of predictability of exchange rates to the carry trade is around zero. All right, so now let me show you the long run risk model, and we can talk about like what wouldn't happen. So I'm going to write down a long run risk model with basically no fun features at all. I'm just going to look at the utility function, and I'm going to show you that I can derive the red line from the utility function. So this is like an Epstein and Zinn utility function, the way that like kind of we teach our students. But we have psi is the intertemporal elasticity of substitution, and gamma is relative risk aversion. And we're going to have consumption growth have a long run component Z. So there's this persistent shocks to like consumption growth, and that's what makes these models tick. Let me kind of just get rid of the short run shock here just to make the math easy. Then, like this is a problem set that I assign my students. Like you solve for the log of M. Okay, it's some stuff here. And then you can solve for the E of M, the expected SDF, and the variance of M. The variance of M. Okay. And you can see from this that if utility is not CRRA, so if you don't have time separable utility, there's going to be a term here in both of these two that is the expected variance of utility going forward. And essentially, this is the part of the model that gives you a preference for early resolution of uncertainty, for example. Right? So that's what makes you want to have information today about what your future is going to look like. And that's really the core thing that these models do. Okay. So as long as we're away from time separable utility, so if gamma is not equal to 1 over pitchfork, then both of these are going to depend on this red term. And I can plug one into the other and I get this. It says E of M equals a slope times 1/2 the variance of M plus a constant. So what this is a functional relationship between the mean and the variance of the log SDF. And it's a functional relationship where people have very strong views of what this is, right? So if I ask Ravi Bansal, what is pitchfork? He's going to say 1.2. Okay, so a number close to 1, but not 1. And what is gamma? It's like 10 or 6 or something like that, okay? So if I plug in these two numbers, I'm going to get a slope close to 1. That's the point. Right? So I now put in the Bansal and Saliastovich numbers, 6.5 for gamma, pitchfork 1.6. Lo and behold, you get a red line that with a slope very close to 1. That's the point. So what this here means is that regardless of what puts two countries apart here on the horizontal axis, now I could have it, I haven't talked about this at all, but I could now have a theory of, why do different countries differ in their riskiness? Like, for example, one country's big, one country's small, or one country has like more persistent shocks than the other country, or one country has more volatile shocks than the other. Any feature of what we call the economic environment, or like, there's a big intermediary here or a small intermediary there, kind of doesn't matter as long as you have a representative agents in the two countries that have the same Epstein and Zinn utility function. Then you're going to get this red line, and you're only allowed to put countries on the red line. If you're only allowed to put the countries on the red line, the model cannot produce large interest rate differentials. End of story. Okay. So for example, if I now put heterogeneity in the loading on a global shock or something in here, what's gonna happen is like, maybe I can do a theory of Japan, and maybe I can also do a theory of why expected returns differ between different currencies. But they're all going to have to sit on this red line. However, there's going to be, unless I kind of change unless I allow differences in preferences, there's no way of getting to New Zealand here. Okay? So proposition, if preference parameters and long-term growth, like mu is the long run, the steady state level of growth, are symmetric across countries, then the FX share is given by 1 minus gamma divided by 1 over psi minus gamma. So it's given by the parameters of your Epstein and Zinn utility function. Furthermore, if agents prefer early resolution of uncertainty so that gamma is bigger than 1 over pitchfork, and assume gamma is bigger than 1, both of those things that we like, then the model cannot match both properties. So they can't have large return differentials without exchange rate predictability. Okay. And for any reasonable parameters, you're always going to get like more than 50% of the currency premium is going to come from predicted depreciations. Okay, so this is a counterfactual prediction that is hardwired in the very part of the utility function that has solved our closed economy asset pricing problems. So this is a little unfair because, like the papers I'm going to cite now, we're looking at very different and also very important aspects of the data. But I basically can now just go and I can look at the preferences used in famous models like Bansal-Niaron, Colasito and Croce, Bansal-Saliastovich, various other Colasito et al. Papers. And I can look, by the way, the only one that really produces large differences in the variance of M is this one. Okay, it's a great paper. Heavy lifting. So it produces a reasonable carry trade of like with a annual return of 7 But then if you look at like the interest rate differentials, they're tiny. So in the data, the interest rate differentials should be something like 4.7. In the model, it's 1.12. And the reason for this is that the FX share, like that, ratio of 1 minus gamma over 1 over pitchfork minus gamma is 93%. So that means basically these guys like did all this work with the economic environment. The hard stuff about that model, right, is all about like having heterogeneity in the loadings on a global shock, having a global shock, solving the model and so forth. None of that's going to matter for this number. Okay. So then I can go. So in the data, it should be a negative number or a number close to 0, but instead it's close to 1. And the same is true for basically everything going back to Bansal and Iran. And that's basically the point here. Okay. So now let me kind of show you basically the same thing for habit models, and then we're going to go to, I can maybe talk a little bit more about incomplete markets if we have time. So in canonical habit models, you're going to write in, so habit models like make me basically more worried about like shocks to consumption that take me close to my habit level. The habit is typically, it's going to be X here. And if you have like a Campbell and Cochrane type habit model, log of M is going to look like this. It's going to be a function of consumption growth and also habit growth. And then if you remember, like when we in the long run risk model, we did like E of M and variance of M. And there was a weird thing, which was like the expected variance of the continuation utility that linked the two. Well, the same is true in the habit model. In the habit model, it's not the expected variance of the continuation utility, but it's how far are you from the habit level. So this link, again, doesn't exist under CRA under time separable utility. It exists only in these sort of like models. So you plug one into the other and you get this. E of M equals slope times variance of M plus constant. Now here, there's actually no guessing at all. Like in Campbell and Cochrane, they actually say, specifically, it says in the paper, because we want to solve the risk-free rate puzzle, we're going to choose parameters so that this is 1. And there you have it. This is not the Campbell-Cochrane, but this is the Verdelhan JF job market paper. Okay, it's not 1, but it's very close to 1. Why? Because you don't want to screw up the risk-free rate puzzle, right? So although that model, like by Adrian, doesn't have any heterogeneity across in the variance of M across country, or it doesn't really have large differences in variance of M across countries, what this is telling us is if we use the same preferences and we came up and we integrated some theory of why the variance of M is different across countries, we would still not be able to get to this red triangle over here because we have to live on this red line. So same problem as before. Does that make sense? Okay. So Dongchen, you were asking about like, can't we have different lines? Yes, you can, but you have to do one of two things. So if you want to have different lines, you just, so basically here's the frustrating thing. Okay. So in grad school, we teach our students that a theory that says, that explains features of the world based on preferences is kind of unappealing because we can show theorems that you can rationalize any behavior under the sun with the right preferences, right? So if you're asking me, can we have different lines? You're asking me, can we just assign different preferences to different representative agents? Sure, you can, but if that's your core theory, it's unappealing. And secondly, it turns out the simple way of doing this, just assigning different time preference rates to different countries, for example, is not going to help us at all. So it has to be like a complicated deviation from having the same preferences in different countries. I think I have a picture for that later. Okay, so but the point is, same problem in the habit model. In fact, I can also show a theorem. If preferences are symmetric across countries, then you can also, again, solve for the FX share without simulating the model. I can just calculate the FX share from the preference parameters. Okay. Again, going to the famous published papers in that literature. The closest paper to data is like, in this sense here, in this dimension, is like Adrian's job market paper. He has actually a large carry trade. This is now the conditional. There's a slight difference here. For the long run risk models, you have sort of permanent differences in the variance of M across countries. Then you can talk about like permanent, like sort of what I call the static trade, which is like you sort your countries once into high and low interest rates and you never change it. This here's the conditional carry trade. The distinction doesn't really matter all that much empirically. Conditional carry trade resorts the portfolio every month. So Adrian kind of gets like a large carry trade, but again, like more than half of it, or so about half of it, is coming from predicted appreciations of the high interest rate currency. And in the data, again, like that's just not what happens. In fact, like we try to have exchange rate predictability, and like we tried to like find exchange rate predictability in the data, and we continuously fail. And the same is kind of true for the other models. Like they tend to have an FX share like around 1. All right. So I have a few minutes, so I can talk a little bit about disaster models. So let me kind of say this a little bit the other way around. So one thing that surprised us is we went to like the disaster because we kind of thought disaster models are different. So like I always think about it, there's 3 models. There's like, long run risk, there's habit, and then there's disasters. But it turns out that like the quantitative disaster models that people like tend to also use Epstein and Zinn utility functions. And then you get the same thing. So Gurio, Zimmer, and Verdelhan, or Gurio in the AER, both FX shares are close to 1. And it's actually also true for the Farhi and Gebex, although they don't use the Farhi and Gebex paper in the QJE. They don't use Epstein Zinn, but they still want to not screw up the risk-free rate puzzle, so they also have an FX share close to 1. So why is the result the same? The result's the same because basically the math is the same. So if you don't have log normal shocks, this RF equation is just longer than it was before. So it's still E of M, not minus 1/2 the variance of M, but instead minus what we would call the entropy of M. This is just like basically it's just the sum of the higher moments or something, right? So it's basically this has in it the 1/2 the variance of M, but then also higher moments. So you can then just relabel. So rather than so the vertical axis kind of remains the same, E of delta S, but the horizontal axis now, instead of looking at the differences in variances, is going to look at the differences in entropy across the log SDFs across countries. And if you have Epstein and Zinn preferences, you get this. So now the E of M equals same slope, now squared times the entropy. But the whole point was that this is kind of a thing close to 1. And if you square 1, you still have 1. So there you go. So this is not a theorem, but this is basically it's pretty clear that the same problem is going to persist. Okay. So for incomplete, okay, so now one thing that you could say is like, oh, people have sort of moved away from, so, I feel like complete markets have a bad name because, we call it complete markets and not efficient allocation. So lots of people are kind of writing models with highly incomplete markets. So think about Gebex and Maggiore and Itzoki Mukin. And essentially what I want you to think of that doing is it basically removes, like everything stays the same, except that you're removing the link between the E of M and the expected depreciation, right? So basically if you have an intermediary that puts like a wedge, so essentially what these models do is they put a wedge between the delta S and the M and M star, and then now that we have like anything can go here, okay? So basically the vertical axis now doesn't really mean anything anymore. It's just the E of M. It's not the predicted depreciation. But the fact remains that I showed you on the first slide that with Epstein and Zinn utility or habit preferences, And again, an intermediary also needs to have preferences. You can't generate large interest rate differentials, period. So here you go. So I can show you, so you can basically, if you just do a little bit of math, if you have basically you preserve no arbitrage and log normal shocks, you can show that the interest rate differential. So okay, sorry, let me back up. Sorry, back up the bus. Think about any model in which home agents can still buy their home risk-free bond, and foreign agents can still buy their foreign risk-free bond. Okay, so that means that this R equals E of M minus 1/2 variance of M, that equation still has to hold. The only difference is that the E of M's are no longer predicted depreciations. So under that assumption, so I have complete segmentation of the two markets, and I'm only assuming that everybody can buy their own risk-free bond and nothing else. Okay? Then and there's no arbitrage. Then it has to be true that the interest rate differential is still 1 minus, this was, if you remember, I flashed this up, this was like the FX share before I plugged in, that the numerator is the delta S, and the denominator is the expected return. Yeah, but this is the same math times the difference in the variances. So the interest rate differential, so basically the key equation that constrains how big the interest rate differentials can be is kind of still the same. It's still the FX share here, right? And the FX share comes from preferences. So one thing that you can then ask, like a different way of thinking about the problem, is like, let's say like exchange rates are just crazy and we're never going to understand them. And but I know that E of RF star minus E of R is 0.048. This is kind of like the return to the carry trade. So let's say I want to make the interest rate differentials, I have totally incomplete markets, but I want to make the interest rate differentials between the two risk-free bonds large enough to match the carry trade. That at least some intermediary, somebody can engage in the carry trade. Okay? And then I can take the preferences from these famous papers and say, okay, let's keep these preferences and we can change the rest of the model. With these preferences, how big would the implied difference in the variance of M have to be? And remember, the Hansen and Jagannathan bound is the variance of M is 0.5 squared, so 0.25. Okay, so 0.25 is a large number. So basically, in order to get a large enough interest rate differentials in any of these models, I would have to have giant differences in the variance of M across countries, even if I make the model arbitrarily incomplete. Does that make sense? So like basically the problem, let me actually just show it in the picture. I kind of said it in the beginning. I'm going to just say it again in the picture. So the issue is this. Forget that this here could be an exchange rate. Doesn't matter. Okay? We kind of said the distance between 0.125 and 0 is large on this scale. If you have preferences that constrain you to the red line, you're going to get tiny, tiny interest rate differentials. Even if you say there's a full American-sized equity premium puzzle in one country and no equity premium puzzle at all in the other country, you're still like the interest rate differential is going to be on the order of 0.5, not 4 percentage points. That's the point. So the issue, the fundamental issue, that with preferences that resolve the equity premium puzzle and the risk-free rate puzzle, you can't get to the point where you get large enough interest rate differentials to match the data, even if you totally forget about the behavior of exchange rates.
So this number is large. That means that if I invest in Australia using Japanese money, I can earn that 5%, which is almost equal to the equity risk premium that we can earn.
Correct.
In the risk-free rate, just in the risk-free rate, not plus the change in the exchange rate.
Yeah, so let's say because we decided, the exchange rates are crazy and we're not going to understand them. It's kind of throwing out the, yeah. So exactly. So but this is what we see in the data, right? So this is like if you take a portfolio of low interest rate countries and a portfolio of high interest rate countries, that is the difference in interest rates between these two. So this actually, I took this number from the first table. Yeah. So the point here is, you can make the market incompleteness. What market incompleteness helps with is market incompleteness helps you make the exchange rates crazy. It does not help you make interest rate differentials large. And the key problem is that the preferences are fixing the level of the interest rate as a function of the preference parameters.
But does that mean essentially these are just two different worlds? Yeah, because how can we earn this if we just want investors, right?
So this is like, look, now here I'm talking, I mean, this is a little difficult because I'm talking about models that plainly just don't exist. Right? So I'm now kind of just showing you, here's a problem you're going to run into. So let's say Oleg, who is coming to my class like in 2 weeks to give a guest lecture. So let's say I told him about this and he said, okay, great. Let me take my model with Dima, and we're going to put in some asset pricing preferences, and we're going to solve this problem. The answer is it's not going to solve the problem, because essentially what their model does is it introduces large degrees of market incompleteness so that the exchange rates can have shocks that don't affect anything else. But that market incompleteness is still, but the key issue was that the interest rate differential was tiny, and making the market more incomplete doesn't make the interest rate differential any bigger. That's the point. So this is a problem that applies to what people refer to as complete and incomplete markets models in the same way. Okay. Let me kind of just say briefly about like the other thing that we were thinking about is, so essentially the reason why we're talking about models that translate differences in variance of M into interest rate differentials is because we see in the data that these interest rate differentials are not reversed by predictable depreciations. So, but there is sort of like, so I call this the risk-based, the finance view of interest rate differentials. The finance view of interest rate differentials is that basically they exist because somebody needs to be making a return for taking on risk. The countries with low interest rates are the countries that have safe currencies. So that's like so this has been, it's a little hard because I'm asking you to back up the bus. So basically, essentially, since the Lustig and Verdelhan AER paper in 2007, people have been thinking about it in this way. Okay. But before that, there were also models of interest rate differentials in macro that just lived in macro models. Like think about like the Mundell-Fleming model, for example. The reason that we find those unappealing is because in those models, there is no risk. And if you have no differences in risk, you can't have differences in returns. So in macro models, uncovered interest parity holds, and there's never an expected return from borrowing in one country and lending in the other country. Okay, so why? Okay, so now why am I saying this? Well, because another approach would be just fine, just modify the damn preferences. Okay, we're just going to say people in Japan are just much more, people in Japan, the US, and Europe are just much more patient than people in Australia and New Zealand. Okay, so maybe that's true. Okay, turns out actually when you measure, that's not true, but it could be true. Well, I have a way of doing this in the model where I just give different countries different time preference rates. Like in my Epstein's inutility function, like before that, there's like a delta, which is the time preference rate. Let me make that heterogeneous across countries. What's that going to do? Well, what that's going to do is it's going to give everyone a different E of M. So basically, you can think of like the finance way of thinking about differences in interest rates is all about the variance of M. But before we started doing this, there was also a macro way of thinking about differences in interest rates, which was always about the E of M. So you're asking me, why can't we just modify the time preference rates to match interest rate differentials? And the answer is, Well, because that would be just a difference in the E of M without having a difference in the variance of M, and is therefore going to induce interest rate differentials that are reversed by predictable depreciations. Okay, and there we have the bloody exchange rate predictability again, right? So so in some sense, the literature has been down this road of heterogeneous time preference rates, and we've kind of decided that this is not a good theory because it doesn't result in differences in returns. So yes, you could give everyone a different delta, but then these differences in delta would be fully reversed by predictable depreciations. Now, maybe more appealingly, you can do the same thing by giving different steady state growth rates to different countries. That we also teach our students not to do that. Why do we tell our students not to do that? Well, because if the steady state growth rate in New Zealand is higher than the steady state growth rate in the US, then at some point the entire world is New Zealand and the US goes to zero. Maybe we can get around that. Yeah. But the point is, by just kind of having heterogeneity in growth rates, you're going to get, again, predictable depreciation. You're going to get interest rate differentials that don't result in return differentials because they induce predictable depreciations. Okay, so it's not so easy. Okay, let me wrap up. So, I mean, I don't mean to like frustrate people here. Okay, so by no means saying that the currency premium puzzle is unresolvable. What I am saying is we've tried for 7 years to write a quantitative model that does what we want, and we figured out that there's a logical problem. It was not a problem of like, the wrong shocks or like, writing the model in a slightly different way. What we figured out is there actually is just sort of like an incompatibility between the finance way of thinking about the equity premium puzzle and the risk-free rate puzzle, and the fact that we want theories of why interest rates differ dramatically across countries while also not having large predictability in exchange rates. So, okay, there we go. And so basically this is the problem with the habit and long run risk preferences. They're magical and helped us resolve so many things in closed economy asset pricing, but they're highly problematic when applied to international economics. Okay, so that's it.
Okay. Many thanks to Professor Hassan for the presentation of this great paper. So now let's switch to Dongchen and for the discussion.
Thanks, Tarek, for presenting this very interesting paper. It actually took me actual amount of time to like understand like the friction here, and it feels like it's like an elephant in the room, and nobody was talking about it until very recently. And I have these like notes here, but to derive these all these equations. So what this paper is talking about is two puzzles here. So the first one is in the standard asset pricing model, we have this equity premium puzzle, but the twin puzzle is this risk-free rate puzzle. So let's take any securities return. So the excess return will be just the negative covariance between the STF and the excess return. So if we wrote it down, we have this correlation term, we have this variance term for the excess return, we also have this variance of STF. What does it mean? It means that higher variance of this STF is related to a higher excess return for any risky security. If we take in the risk-free rate, we can rewrite this equation into this form in which the risk-free rate is just a combination of the expected value of the STF, meaning that if we have a good news, EM is lower, we have a higher risk-free rate. If the variance of the STF is higher, we also have a lower, we will have a lower STF because volatility news is a bad news. So we have these two components there. And in a standard capital asset pricing model or a consumption capital asset pricing model, we have this hard time to reconcile with a high equity premium because overall this variance of the SDF is quite small. Well, at the same time, we see that the risk-free rate is too high because we don't have much variation in terms of the SDF. To reconcile this, we have a couple of models of disaster risk, habit, long-run risk, to try to reconcile a high equity risk premium puzzle with a low risk-free rate and stable risk-free rate. So what they do is they first come up with something that gives you a higher variance in the SDF, which push up the Hansen-Jack Nathan bonds. While at the same time, they want to keep the risk-free rate low. So what they do is they make this covariance between the mean of SDF and the variance of SDF to be negative. What does it mean economically? It means that when there's a bad news coming in, your intertemporal marginal rate of substitution is higher, then your SDF is going to be less volatile. What does it mean? It means that not only you started to save, but also you started to do some budget balancing going forward because you have this continuation of your utility. So you plan this, you go to your credit card balances and figure out what's going on day by day, so you have less volatile consumption going forward. And that's what you would do when you have bad news happening because you don't look at your credit card balances if you're rich. Well, if you're not, you're starting to care about your balances. And this is what we see in some canonical long-run risk models as well as habit models. If you have lower conditional expected utility, your variance of this expected utility is also going to be lower. So again, what does it mean? It means that when you don't have much utility, you start to starve. You try to lower your volatility of your continuation utility because you don't want to suffer too much from this uncertainty going forward. So you have this early resolution of uncertainty. You want to balance your budget so you don't have volatility in consumption. But that's a good news for you because you have recursive preferences. By doing so, you don't have to save as much. So indeed, you have these countervailing forces, which lowers your savings on average, but at the same time, the risk-free rate is going to be lower because of the bad news. So the second puzzle here is going to be the currency premium puzzle. So it all started from Fama, who talks about this for premium puzzle. When we run the regression on the left-hand side, domestic currency depreciation, on the right-hand side, the risk-free interest rate differentials, by UIP, uncover interest rate parity, we will assume that this beta is exactly equal to 1. If I have high currency, depreciation will wipe out that gains from interest rate differences. But what he finds is that, okay, I have a high interest rate currencies that tend to appreciate. What's the implication? The implication is that excess returns are driven by both interest rate differentials, which is positive, but also the currency appreciation, which is also positive. So that was actually a supportive evidence which supports these past previous literature like Palestine and Krause, Verdenham. What they were trying to match is trying to give a solution to this pharma puzzle, and they realized that, wow, the domestic equity premium puzzle can be exactly implemented to this currency premium puzzle. If I solve this risk-free rate puzzle with this negative covariance between mean and variance of SDF, I can also use this same tool to solve this pharma puzzle. So taking a step back, in the complete markets, expected depreciation is going to be just the difference between the means of the SDF. Well, the FX risk premium is going to be the difference in the variance of the SDF. So how do we explain this Fama puzzle in which when we see a high risk-free rate, we see domestic currency appreciation? So if we just have this means term, we cannot do it because whenever risk-free rate rises if it is associated with a drop in my average intertemporal moderate rate of substitution, then it's a good news that always makes consumption more abundant in the domestic country, and that will pushes down the domestic currency because I have more money to consume. I make my domestic good relatively less expensive compared to the foreign good. Okay, so that was the standard UIP. However, those models who can solve this risk-free rate puzzle can also be implemented to solve this Fama premium puzzle, in which if this risk-free rate rises is coming from a lower volatility of the SDF, then by this construct of the negative covariance, I can push up a little bit of this IMRS. Why? Because I do less budget balancing, then I will care about my continuation utility. So I save relatively more than I should have today, which pushes the domestic currency up. So if the second channel dominates, then we will see positive covariance between the risk, interest rate differential and the domestic currency appreciation. So the new puzzle here, so the new target here is we actually find that, wait a minute, this high interest rate currencies has a high FX risk premium, not because they appreciate, but because they have this large interest rate differentials, which is persistent. So the returns are not coming from the expected appreciation of domestic currency, but actually coming from this large interest rate differentials. So this is what the friction is. The key friction here in the first place is we have this Fama puzzle which predicts the interest rate differentials and appreciation to be negative. Well, today, if we look back into this Fama puzzle, we might see that, well, the covariance is actually negative. Sorry, not negative, but zero. So those models who are trying to fit in this Fama puzzle, try to solve this Fama puzzle, will not necessarily fit into this Hassan and Mano new target. So indeed, we would probably examine what.
Can I just jump in here? Like, so we were polite in writing that paper, but now I think I can say we just think that this Fama condition is just wrong econometrics. It's just not correct.
Mm-hmm. Yeah, so I will show you in a second. So that this is exactly. Well, I'm not trying to say they're econometrically wrong, but just a simple regression to validate whether this condition still holds, especially in.
Great, but let me just clarify.
Yeah.
If you can go back one slide, like we didn't write this, like we wrote this in earlier versions of the paper, and then like we were scared and we just didn't write it because like, Gene was so. Basically, to get the Fama conditions, you need to write this first regression on the slide. That is always insignificant if you run it one country by one country. And to get it, really, you're running a regression with alpha I with a country fixed effect. And you're not allowed to interpret coefficients from a regression with fixed effects as predicting anything about the future because you don't know what the fixed effect is. Not a predictive regression. If you correct for that, there is actually no evidence that this coefficient is negative. So,
well, I should say, even with that, so I totally understand, like in Hassan model, you you addressed that questions. Because if we run fixed effect regression with the prediction, then the fixed effect itself has some prediction components in it, which sort of boils down to this beta. But even with that problem, I think if we look into the data over the past 25 years, we see much weaker evidence related to the pharma. So let me show you what's going on. So I sort of doing some replication exercise on this pharma premium for premium regressions. So what I do is I regress this 1 month FX risk premium or the 1 month change in exchange rates, so depreciation over this 1 month interest rate differentials. So if you see, like Tarek said, if you look at just regression by regression, you don't see much significance here, right? So that was the problem when we do panel regression. Maybe it's because we have a much weaker sort of significance power when we do like currency by currency. If we pull it together, you will see the excess return coefficient is going to be 1.3. What does it mean? It means that if I have 1 percentage point increase in the interest rate differentials, it is associated with 1.3% higher excess return from time t to t plus 1 month. Okay. And if we just look at the depreciation, because this is just a pairing, because FX return is equal to depreciation, appreciation plus this interest rate differentials, don't see much significance, if any, in terms of the depreciation. What does it mean? It means that most of this FX risk premium is coming from the interest rate differentials, and this is a panel time series regression. So we have this currency fixed effect is doing from 2000 to 2024, which means over the past 25 years, you see this change, revolution of the regression coefficients getting more into a sort of a stable regime, that most of these FX risk premium is coming from the stable interest rate differentials. If you look at the cross section, on the left-hand side, we have a depreciation on the y-axis. On the right-hand side, we have excess return. And it's, in the cross-section, you can also see that most of these higher risk premium is coming from the interest rate differentials. So we have this 45-degree lines here, which is in gray. You see it almost matches this 45-degree lines, while for the depreciation, it's almost zero. So what does it mean? It means that high interest rate countries like Australia or New Zealand have has a higher risk premium, not because they have a high appreciation in their currency, but because they, in general, have a higher interest rate differentials compared to the home country here, which is the US dollar. Okay, so that means that if we are trying to update our models, we should get a new target, which is saying that most of these currency risk premium is coming from the excess interest rate differentials rather than the predictable currency depreciation. Okay, so once we have that, we have a problem, because what we want is we want to have this variance of interest rates mostly coming from the variance in the SDF. Why? Because if it is mostly coming from the mean of the mean differences in SDF, then we will have UIP. So what we also need is to have a vertical line, like Tarek was mentioning. We should have this covariance between the mean and the variance of SDF is getting closer to zero. So the FX premium will essentially move 1-to-1 with respect to interest rate differentials. But that also means that we miss this risk-free rate puzzle. If we are trying to fit in this, we're going to miss our puzzle one, which is the equity premium puzzle or the risk-free rate puzzle, since if we don't have this, then we'll have a volatile risk-free rate. And indeed, even without this, even with a negative covariance, some papers like Nieder and Campbell, they mentioned that, well, this volatility of risk-free rate is already too high and is correlated with consumption growth. If we remove this, we're going to have an even higher volatility in terms of the risk-free rate. And that becomes a puzzle. And not only that, we need persistently high versus low variance of SDF across countries if we assume that they are in the same functional forms across countries. Perhaps one solution would be some regime-dependent covariance between the mean and the variance of SDFs, saying that I have large drop or increase can happen sometime. Well, on the other hand, most of the time it is in a stable regime. Perhaps it can help reconcile with this fact. On average, this covariance is like 0, but sometimes it's positive, sometimes it's negative. And if we look at time varying coefficient, if we do like a rolling regression of the Fama regression, you do see the coefficient changes time over time. It's not stable at all. So in conclusion, we have this new empirical target from Hassan model. I think Tarek briefly mentioned that. I just want to bring it back to the table. The core intention is that we're matching this new target, but matching this new target requires some friction that could destroy our classic solution to the risk-free puzzle. I like this paper about this pinpoints on where the model fails. We have this beautiful graphs to see what the tension is. Tension really is the mean, the covariance between the mean and the variance of the SDF, which opens up a lot of new questions to the future research. Right. Thank you very much.
Okay, many thanks to Dongchen for the wonderful discussion. I can tell it takes a lot of efforts for producing these slides. So, like Professor Hassan, do you want to respond to some of the points Dongchen has brought up?
I think it's great. Like I didn't quite get like I was looking at your slides over breakfast. I didn't quite get it, but I think that's perfectly. I think I agree with everything that you said. Um, so yeah, I don't know. Do you want to? Yeah. So I don't. I thank you. That's great. I'm gonna read through that. So I need to process a little bit.
Yeah. So one question I have is like, if you need if you do assume the same functional form or at least the same SDF structure across countries, isn't it hard to produce interest rate differentials? Maybe that was your point, right? So your interest rate differentials must come from some endogenous subject because interest rate itself is endogenous. If we're trying to match the equity risk premium, we must have a low interest rate in the first place. And all these papers, they're not trying to like factor in there's another country. And if you factor in another country, first of all, as who is the margin investors for the risk rate in another country? Is that domestic investors or the foreign investors? And
So
yeah.
I think this links to. So I think there's a general view that I have that in some sense closed economy asset pricing theory is extremely well developed. But there's a massive hole in the literature when it comes to what do our classical sort of like portfolio results look like when you have more than one country? And it's really almost striking how little, like all the textbooks kind of stop. So let me kind of just say, so why am I saying this? It's sort of like from what you're saying, like an obvious next question is what does the equity premium puzzle look like in New Zealand?
Right, right.
Right?
That's right.
And I would claim that, although there's sort of a large literature that kind of had an empirical approach to this question and just said, okay, like the New Zealand stock market is a New Zealand stock market, and we're just going to look how that relates to the world stock market. But if you think about it from the perspective of these models, what the models say is that that's not at all the case. So what the models say, and I had like when Matteo had his job market, when I discussed Matteo's job market paper at the NBR, I had like these pictures that I made about what does the mean variance frontier look like when you have more than one country? And what does it look like if I'm American and I'm looking at the French mean variance frontier, which is then to the interior of my investment opportunity set? And there's some interesting results there that were never developed. So in the sense that, like, for example, figuring out what is like, so from, like taking these models seriously, what is the difference in the equity premium across countries? And I think what we're going to get is like there's a bunch of there's sort of interesting theorems. I have like a bunch of them in my homeworks that I assigned to my students. There's interesting theorems to show about like, for example, the country with the low interest rate under in a very broad country class of models, the country with the low interest rate has to hold a safer portfolio. So that means in equilibrium. So think about this for a second. So if I have a theorem that says that the country with the low interest rate, it makes sense. I have a low interest rate because I have a high variance of M, which, I would just like, if I had to explain to my mom what it means to have a high variance of M, I'm kind of generally scared and I want to do precautionary savings. So I have a low interest rate, right? If you think that of that from the perspective of mean variance analysis, it's basically going to imply that my efficient frontier is going to look very different from yours, right?
Right.
So rather than talking about the equity premium, then what you have to talk about is the returns that you earn on the portfolio that you hold in equilibrium. And there's implications in these models. I can show you, like, in New Zealand, those returns are going to be much higher than in Japan, for example, right? So investors in New Zealand should be holding riskier assets and providing insurance to investors in Japan. That's like, I can tell you, like, so if you solve the model, even with time separable preferences, that's what you're going to get. So why am I saying this? I'm saying this because I think, like people always say, like, the closed economy asset pricing edifice is sort of like done, and we have to like now do other crazy things and like and move on to other things. That is not true when it comes to international asset pricing at all. Like there's basic questions that I've just been amazed that like people are not working on. So yeah, there you have it. So I think, this is like, I don't know if we're going to do this, it's going to be an effort to both understand like in more detail, like sort of, there's this duality between interest rates and portfolios that people should be holding. There's actually exciting stuff happening, and like we now know a lot more about these portfolios. Yeah. So why am I saying this? I just think there's a lot of work to be done, right? And there's no reason to get frustrated and say, oh, we don't know how to do it. Like I think there's lots of ways of like resolving these issues. It's just going to take a little bit of work, like in the same way that the equity premium puzzle took like decades of work.
But at the same time, do you think the same function form can be applied outside of the US, or the parameters will be the same largely, but just like the model will be different?
So I think from a philosophical standpoint, I mean, I was raised in a tradition of thinking about economics where the last resort is modifying the utility function. And I've shown you that even if I now kind of got myself to do this and say, fine, I'm going to modify the utility function, it's far from clear how to do it. right? So
Okay.
it's not even easy to do that. I can tell you like one really simple fix to all of this is to say, okay, screw it. I'm going to do away with all of the fancy stuff that was invented for the equity premium puzzle, and I'm just going to say, um, Thomas, Ginny, and I had like a paper in the Brook. We had to write a Brookings paper about who's going to be the new anchor currency of the world. And we actually have like a model that had something to say about this, but it's not quantitative for the reasons that like outlined in this paper, right?
Mm.
So, how did we make it quantitative in like 4 weeks? Is you just ex assume massive market segmentation. Okay, like so basically you can get the numbers to work if you assume that less than 3% of world wealth is engaged in financial intermediation. And then, you can get like interest rate differentials to be large. I haven't solved for the equity premium in that case. I think it's probably going to
Mm.
be like off the chart. So there are other approaches, I guess I'm trying to say, that
Mm.
don't rely on these two utility functions. Um, Jinya has like another approach where he kind of like messes with parts of the habit function. Uh, the habit function, like if you think about it for longer than a minute, it takes a while to think about it, but like if you have like a habit process, I would loosely say that's a preference parameter that governs that. But it's sort of a mix actually between a preference parameter and a feature of the environment.
Mm.
You can, you could sort of think about doing that. Then you also get different lines. Um, yeah.
So essentially, if we just take the consumption-based model for granted, it is going to be very hard to reconcile with the differences in terms of the interest rate differentials.
But I don't know if there's actually a way of getting away from the consumption-based model, right? So I think that like there's sort of just very strong forces in like equilibrium theory that like somewhere someone that needs to be interested in consuming this stuff.
Yeah.
Uh, so look, I'm not a friend of like this idea. So my view is that like the literature has made great progress when talking about intermediaries and so forth.
Hmm.
But I think people are confused about one simple thing, which is like talking about intermediaries is basically just saying the market is segmented. There are specialized agents who can trade across one asset class and another asset class.
Hmm.
But it doesn't mean that you get to write down whatever utility function that you want for those guys, right? So it's
Yeah.
all the same problem. They still need to have utility functions. And the first generation of these intermediary-based models kind of like took the liberty to just say, okay, I'm going to do mean variance. I'm going to do whatever I want over here.
Hmm.
But the same logical problems exist. So I think so. My sense is that like so this is to say that like there's kind of no alternative at the end of the day to like the some version of the consumption-based model.
Yeah.
Um,
Yeah. I know
if
there are some papers trying to like reconcile it in another way in which like production will be different across countries. Like recent paper by Kogan, Dimitri, and Qiu Shi. So they were trying to use like innovation and productivity. Like you try to reconcile the problem with respect to like US dollar appreciation and like innovative productivity like pattern. They find a success there. So I guess like perhaps the consumption base is not the final way to achieve that. Maybe if we
you
have
think this is like a production-based view, which is also fine. I mean, I think it's just at the other side of the equation, right? It's just
mm,
in some sense, the production-based asset price is also consumption-based asset pricing. It just looks at the other side of the equation when going to the data. It's the same equation.
but essentially you need different productivity parameters, which boils down again to another like parameter changes to reconcile with the interest rate differentials.
Okay, so that I don't know that paper, so I'm not
Hmm.
sure. But like I would like to, I don't want people to read this paper as like it's all depressing and there's another problem and so forth. What I want people to read this as there are basic, sometimes in economics you feel like all the easy stuff has been done and like, I think I want people to read this as there's a lot of work to be done in international finance. And
Yeah.
like just think about how much work it took to develop like to figure out that like a resolution to the equity premium puzzle. And why do we think that it's so much easier to go from like one country to like 200, right?
Mm.
So in some sense, we like, I don't know. Sometimes I feel like we figured this out for the US. Now let's add the other countries, and then, somehow it's supposed to be easy to do that. So,
Yeah.
I think like, so, so what I want people what I would like to say is that there's still room for basic theory to be developed, if you have more than one country. And essentially, one way to figure this out is like you take Campbell's textbook and you read it, and you will see there's no chapter on international finance. And all the things that he like derives for M, there's a question like what happens when you have M and M star? That's basically the point. Right? And I think that's underdeveloped, and like sometimes we're like, unkind when we're referees. We're like, you should know that if we have M and M star, it's like this, but like it's not, the literature's really not well developed.
I agree. I
There's a
totally
lot of
agree.
work.
Thank you very much. Thank you very much, Tarek, for the great seminar.
Yeah, thank you very much. I think this is a quite inspiring paper. So like it could inspire people to like solve the international puzzles in a different way from what we have at this moment. Um, Okay, if there are no other questions, let's thank Professor Hassan and Professor Zhou again for the great presentation and the discussion. And that the presentation is great. And then I will I have recorded the video. I will share the video with Professor Hassan once it's done. So thank you very much. Have a good weekend. Yeah.
Thank you so much.
Thank you.
Yeah.
Bye.